Hello, everyone. I'm Yusuf Aykin, and I'm coming from Germany. And our paper is about enhancing robotic vision through deep learning techniques from detection to construction. So when we say construction automation, there are few challenges we have encountered. Those are constructions are highly dynamic and chaotic. It often contains different materials and textures. There are multiple objects in different scales. It's unpredictable. There are also human factor in the construction. And to automate in the construction scenes, that we need to computer vision perception that can do object detection, segmentation, and scene understanding, and accurately, precisely manipulate the robotic arms. So for our paper, we start with collaborative lab scene. We have three different scenarios. First one is in the lab scenario. Second one is more like a real life. And the third one is our vision in the construction site. So our objective is accurately detect objects, their description, and manipulate it. And we will transition from the lab to real life scenario. This is our methodology that contains all the steps, and I will be going over step by step from capture and point cloud and robotic grasping. For point cloud capturing, we are using SICK Visionary S camera that is able to capture until 60-meter range, and it has a color. It gives us a color point cloud, and from there we project our 3D captured point cloud to 2D domain to work on the further processing. And the reason we are projecting in 2D that we have more training data on 2D based detections. It has higher detection accuracy. We can easily annotate 2D images by bounding boxes, and it has lower cost on computation. For object detection algorithm, we are using GroundingDINO, which is a zero-shot algorithm that already trained with billions of images. We input our model with text prompt and image. The text prompt can be any class name that it has trained on. It has trained thousands of different classes, and it gives us the result of 2D bounding box. And using this 2D bounding box, we insert it to another algorithm called SegmentAnything, created by Meta. It's also zero-shot algorithm. And its function is that it segments the pixels within a given image and bounding box, and it also creates a instance mask based on detected objects. And from there, using those instance masks and 2D point cloud, we are able to combine these two to get a 2D colored point cloud. And we project this 2D point cloud back to 3D to get a color-coded 3D point cloud. From here, our point cloud is currently playing in the 3D space. We need to calibrate it to the real-life position. To do that, we are using iterative closest point algorithm that it tries to match the guide point cloud with our target point cloud step by step. From here, for each detected instance, we are trying to find its grasping position for the robot. For each target, we apply ransack plane segmentation to get the most planar surface, and then we find its orientation plane and draw for minimum bounding box with grasping lines and normal vector for robot to grip. Our robot grasping algorithm is based on a few steps for a simple pick and place task. And we use inverse kinematics for UR10 robot to get the robot rotation axis to send it directly to robot for our tasks. For our results, we are able to accurately detect 95% of our blocks. And from those detections, 89% of them is successfully segmented to pixels. And we are able to pick and place 93% of the target objects with a 3-second time frame. We have few limitations in our model. The first one is that we are using a color sensor, and it's very grasping. There are grasping failures in the reflective surfaces and distant objects. And the second problem is that it takes 6 seconds on our local machines, and it's not viable for real-time applications. And the third one is that we are using single robot and single viewpoint, but we can increase that in the future. And in the future works, we already start working with other implementations. For example, this one is that we directly speak with the robot that which task it needs to be done. And it's able to get the blocks from the scene and place it in a with our intent using ChatGPT API and or prompts. And the final step, we are able to switch to stage 2 with manipulating with the real life block position in the construction environment. Thank you.